One, two, one, two. Can you hear me? Yeah. Hello, everyone. Hi. My talk today is about building dApps, but more specifically, building dApps on top of a light client. So first of all, I want to start by show of hands. Who here is a dApp developer? Has built some dApps in their lives? Some of them. Okay, cool. So I'll present myself. My name is Amaury. You can find me Amaury Martini on GitHub, on Twitter, on Reddit, etc. I work at Parity Technologies. I mainly do JavaScript and dApp stuff. I'm also the author of Light.js, which I'll talk about, and I contributed on Feather, which I will also talk about. And I'm currently working on Polkadot.js, JavaScript on Polkadot and Substrate, and some UA stuff. So today my talk is gonna be separated into three parts. First of all, I'm going to answer the question: why do we even want to build dApps on top of Light clients? Second part, how to hack with Light.js, JavaScript library. And third part, a small and quick demo of Feather, which is a Light node inside an Electron app using Light.js. So let's start then with the first part. Why are Light clients important? Why to build dApps on top of Light clients? So today, running a full node, as we all know, is a pain in the ass. Some stats about Infura, which is the main provider for dApps today. They, at the beginning, they helped a lot the dApp community to grow because it's super easy to configure. You just have one line to add and you can connect to Infura pretty fast. However, these are some figures I found on the internet. They serve around 10 billion requests per day, and 35,000 dApps depend on Infura, which this kind of creates some kind of centralization over this, massive services. And the idea is, can we be a bit more decentralized? Light client can offer such a solution. So what is a light client? I'll go pretty quickly on this because I suppose you all have more or less an idea. So light clients are nodes on the network that only store headers, so no states, but still can guarantee some sort of trustlessness and some sort of security. So comparing to a full node, the sync time, instead of days, we have sync time of about less than a minute, couple of seconds. State size, a full node has a couple of gigabytes on your hard disk. With a light client, there's no state. And the DB size, the total database size of your node, well, with a full node, it's also tens of gigs. And with a light client, it's a couple of megabytes. So it can totally live in low resource environments like a mobile phone. So why should we build on top, should we build dApps on top of a light client? Let's say this is my dApp. Today, when you create a dApp, you don't think about the node. You just look at some centralized service, typically Infura or MetaMask, which also uses Infura on the backend. And you just tell your dApp to connect to that provider. The provider kind of controls your dApp in this case. So what could we do? We could also look at the other kind of nodes that are in the network that are called light nodes, the ones that I explained, and transform your own dApp into a light node. So that in this case, if your dApp is a light node, it's like any other light nodes in the network. It can connect to any other nodes on the network. So it can have a lot of other providers on the network, which means that your dApp no longer depends on the centralized services. So I learned yesterday that Status is planned to do something called Chaos Unicorn Day. I don't know if you heard about it. Basically, the idea is on April 1st of this year, they'll try to shut down all centralized services, including Infura, Etherscan, and all big ones for 24 hours to make it as an experiment to see if the Ethereum network will survive this 24 hours, what will break, what will not break, if Ethereum is really centralized as we think about, or if there's some stuff to do on this way. So typically, light clients would be a solution to this. Any dApp that's worked on top of Light Client will still work on that day. It's called Chaos Unicorn Day. Look it up on Google, you'll find it. So now let's get a bit more technical and talk about light.js. So like the dApp, when you're creating a dApp, the stack, like today, before, your dApp is basically an UI and a library, typically web3.js or similar library that will manage the provider and provide you with all the functions that can communicate with the blockchain. And so this web3.js or this library will connect to a centralized service node, and the node will talk to the network. So that's the current situation today. And with Light clients, it's a bit different because your dApp will now be a bit more. It will include a Light node inside it. And instead of using web3.js at Parity Technologies, we made a special library called light.js that will communicate with a Light node inside your dApp. So when you create your dApp, the provider will be the local Light node, and it will be the Light node that will communicate to the rest of the Ethereum network. So on your side, on the dApp developer side, there's a bit more work because you need to take care a bit of the Light node. So light.js, concretely, what is it? It's a JavaScript library. It's high level, it's reactive, it's easy to use. That was our first objective when creating light.js. So as easy as npm install at parity /light.js. So here's some code on how to use it. First of all, you import lights and some functions that are inside light.js. The second line here sets sets the provider here. So the provider typically will be your Light node. It won't be Infura or it won't be a MetaMask. It will be your own Light node, so localhost and some port. And then I'll remove this mouse. And then to call, for example, the block number, here we call the block number function. And here the block number returns an observable. I'm not sure if you're familiar with observable in the JavaScript world. They're like promises, but a bit more complicated and a bit more performant and way more with way more functionalities. So here the subscribe you can just imagine as a then in the promise world, but instead of returning only one value, the observables will continue returning values as they change. So the block number here on each new value will log the current block number and the block number. Same thing for the balance of function, which takes as parameter an address, a public address. And with the observables, you can also pipe some functions, which means that you take the value, the first value, and you apply some functions in a sort of a functional programming way. You apply some functions, and the result at the end and on the subscribe will be the first result with all the functions passed through. So here we log the balance, and we format it a bit nicely with 2 digits. So the result will be on the first log, we'll have the current block number and my balance. And each time your Light node receives a new head, it will log a new head number. And each time your Light node receives a new state, your new balance, it will also log the new state here. So it will do this reactively. It seems like it's a push mechanism, but it's not really a push mechanism. Light.js handles all the tricks behind so that it's easy on the Light node. Today, Light.js only has 12 functions. That's all. We still have the keep it simple mentality with it. But with these 12 functions, there's a lot of functionalities that can be built on already. And the proof is that I'll show you a demo of a wallet, fully functioning wallet that we've built. And if you're into React, we also have a specific library called Light.js-React for easy integration with React. So you may see that it seems similar to Web3.js. It's kind of similar. There's some difference also. It's definitely a replacement for Web3.js. First of all, the async, how do we manage async calls? With Web3.js, it's promise. With Light.js, as I said, it's observables. JSON RPC coverage, Web3.js has all the JSON RPC. Light.js, we keep it simple and we listen to the community. So if you want to see something inside Light.js, add an issue on our GitHub repo. And is it light client friendly? Web3.js could be light client friendly, which means it could be, if the developer does it, it could be not so resource intensive on a light node. And light.js, by default, if you use any function inside light.js, it will work well on a light node. So I'll go more into this point more specifically. Why Light.js is light client friendly? So behind the scenes, Light.js basically managed to use the least possible resources it can to make your dApp work. So for example, it only fetch states on new head and only fetch states when you want some state in your dApp. If you don't want, it doesn't even fetch the new head. It creates and drops subscriptions, either HTTP subscriptions or WebSocket subscriptions, only when needed. And if there's no one listening to any subscription, then drops everything. It handles cache, and overall, it's the least amount of network calls that are made, because network calls on the Light node are quite expensive sometimes. So the least amount of network calls are made. And that's the goal of Light.js. And third of all, Light.js does not track users at all. There are some articles about Infura tracking users and handling some statistics about them. Light.js does nothing about this. If you have your own Light nodes, it will not track your users at all. Your app will not track. So there's a fourth point, but I didn't want to put it here because I don't want to advertise so much. But if you want to try today without a Light node, it's still possible. Light.js also, despite the name, works with a full node, works with MetaMask, works with Infura, works with everything. But the way we want to see the community grow is to get away slowly from these centralized services. So if you want to get started now, just go to this URL. There's a README, there's a couple of guides. I'll leave 5 seconds for you to take a picture. Okay. So the third part is demo. I'll show you a demo. So the internet wasn't so good, so I'll show a video demo of this. Our goal is basically, like, as I said before, is to embed Light clients a bit everywhere, in mobile phones, in browsers, and desktop apps, so that we can facilitate mass adoption of Ethereum while maintaining decentralization. And our proof of concept today is Feather. Which I will demo right now. So to quickly present Feather, Feather is just a simple wallet. It's just a wallet to manage your ETH and some ERC20 tokens. That's all. You can send, receive, and that's basically all. So if I play this is when you download Feather. You see some terms and conditions. It's downloading. You see basically up there that Feather is basically a menu bar app, so that it will always live on your desktop. It will always be connected. It will run on startup. It will always be synced, and it doesn't consume much resources on your computer. So this is our goal with Feather. It will download, and here it will download the Light node, and here you will see it will start syncing. Now it's 1%. You just wait a bit for it, connecting to peers. So this is a live screen that I took yesterday. And it will take like 10 seconds, 15 seconds maximum to be synced. Here you'll see in 15 seconds it syncs on the Kovan testnet. So the trick we use in Parity is that we actually hardcode the latest headers for the Light headers. We hard-coded in the Light node. That's why it syncs in like less than 15 seconds. Our aim is to always keep it under 1 minute, so that it's not such a big user, UX flaw. And after that, you can just start hacking on Feather. So let me see here. I have a synced Feather. So when you open it, you have your list of accounts. As you see, it's a menu bar app. If you go on the main page, you can see here, and you can add and remove tokens. I think if I try like Gavcoin, there's something like Gavcoin. Whatever. So you can just basically send, receive tokens. Here it's taking a bit of time because I think the internet's not so good, so it has trouble fetching the balance. Hopefully we'll show it sometime soon. If not, it's not a big deal. Well, anyways, I'll continue with my slides. So this was Feather. So Feather is the first truly decentralized wallet. There are other wallets out there, but they rely on centralized service. This is the first one that is completely decentralized because it has a light node embedded in it. It uses light.js. It's bundled, bundled, like as you see, it downloads parity Ethereum Light client. Everything is done under 1 minute. It uses another library called Parity Electron, also inside us, which will manage the light node. We'll start it, fetch it, we'll stop it whenever we want from a Node.js environment. It's a desktop menu bar app. It will always be running and always sync on your computer. And we try to make it as a simple UX. So here are like some screenshots, the same that I showed you before. If you want to download Feather, you can download it right now. So it's still in a beta stage. There's a lot of work going on. We're planning to have it audited in the next month. We're planning to also launch it on mainnet because today we are still in beta stage, so still on Kovan testnet. In the next month, we'll have a pretty well-functioning Feather. And for example, for the Chaos Unicorn Day, Feather would be a perfect solution to send your tokens and send your ETH. So quickly about the Feather technology stack. So it's an Electron app, and as one of the first slides I show, it has a light node embedded inside the Electron app, and it uses Light.js to communicate with the light nodes. So it also uses some other parity JavaScript libraries. If you want to have a look at this URL, these are all where we conglomerate all our JavaScript libraries. So Light.js, React, I already talked about it. Uses a bit of parity API, which is kind of old. It's our own Web3.js. It's promise-based. It has PubSub support. We still use it. And also parity Electron to manage start and stop the node from Electron. So where to embed next? Our plan, as we said, to embed everywhere this light node. So now we have the Electron app. Next step, we think, is Android and iOS. We had a third party which we're in touch with, which tries to do it on iOS with the Parity Light client. On Android, we managed to have it running. So we managed to have a light node running Android, a UI that communicates with the light node and fetches balance, etc. So it's working, but we don't have actually enough resource to work on the UI stuff and the Android app itself. Then in the further future, we would like to see Feather as a browser extension, a bit like MetaMask with a light node inside the browser extension. This requires some work on the node side. So we need to compile Parity Ethereum into WASM so that it can live inside your browser. And even in the further future, why not to have Feather as a pure website where you go and it syncs in like less than 10 seconds and you have a functionally decentralized wallet as a web page. So if you want to have a light client inside your project, come talk to us. We'll be around here. Either me or Thibaut, which is sitting also in this room. We can talk to you about Feather, about light nodes, about Light.js. Thank you. Thank you very much. Any questions?
Hi. I was just wondering on the Feather list, we had the actual website example as like at the bottom of the list. What was the big challenge in demonstrating that over like the download?
So you mean this one?
Yeah.
These one are our next steps. So we don't have actually these stuff. For the Feather as a website, the biggest challenge is to have a node inside your browser. So it can only be two solutions, either in JavaScript, but JavaScript is slow. It won't be super performant if you write your full light node in JavaScript. Or the other one is called WASM, which is a new language, well, kind of new, like already 5 or more years old language that has native capabilities, almost native capabilities, and that run in your browser. So that imagine you have your JavaScript library that has some native WASM code. Your light client will be in WASM. The website will run this code in native performance and will sync your light client in 10 seconds. So that's the idea, but the biggest challenge is today to compile parity Ethereum into WASM. So it's written in Rust. It should compile to WASM pretty easily, but because of a couple of libraries and incompatibilities, and also because of dev P2P today, it's quite hard to compile to WASM. So I would say it's not for the next 6 months, but it's something that we're working on and we really would like to see. Thank you very much.